Hello, welcome to Odor Always Moves, where we're translating the complexity of odor movement down to the operational level for both canine trainers and handlers. This is the 10th video in the series, and we're going to be talking about buried hides, specifically diffusion through materials, so how the gas moves through different soil types, and the impact of surface vegetation on how much of that odor is going to be available once it gets to the surface. As always, these videos are dedicated to my first bomb dog, Daisy. These videos are just for educational purposes only. They are not meant to quantify actual odor availability in the real world. We do the best we can to make it as realistic as possible, but again, this is just to give you an understanding of how odor moves, not trying to say this exact amount is going to be actually available. Many factors do influence odor movement from buried hides. And obviously, one of the main ones is depth. How deep are you putting that hide, or how deep is it? Is the source of the odor? And obviously, if you bury something deep enough, odor's not going to reach the surface for so long that it's really irrelevant. Okay, but for all practicality, most buried hides that the canine world is dealing with, be it human remains detection, explosive detection, or even like pipeline leak detection, the depths buried are going to be within the range of providing odor availability for a dog. So, but it factors greatly in how long it takes for the odor to get there and how much is going to be at the surface. The other big component is the soil profile. Now, what that means is the types of soils and the thickness of it between the source material and the surface. And then what's going on the surface, the wind direction, the vegetation, and the terrain. So those factors are the main influences on how much odor is going to actually be available. So something to kind of keep in mind is when we talked about this before is how odor moves in terms of on the molecular level. And the molecules of the gas are bouncing off of each other. They're bouncing off molecules of the air, and they're bouncing off any molecules of materials that it can't pass through. Okay, and this basically comes down to Fick's law of diffusion. So those molecules bouncing around, that's defined by that law and how fast it moves. So in the air, obviously, odor can move very quickly because there's this big space between molecules, and the gas molecules can bounce around and move very quickly in that environment. And what's defining that is the void space. So we're dealing with, you know, very solid materials, but even with them, there's airspace between the molecules, or not the molecules, but the particles of the soil types. And each soil type has a different void space. Now, the larger the void space, the easier it is for the odor to move through it. So clay has actually a very small void space because the particles that make up the clay are really, really small. They're very tightly put together. So the amount of air between each particle of clay is not very much. And so because of that, odor moves very slowly through clay materials. And that can also depend if it's loose or it's compacted. But then sand, and even though like a fine sand, there's actually a lot more void space compared to clay, and so the odor can move very quickly through sand. And then loam, which is essentially just like topsoil, and that's a little bit slower because even though there may be some good airspace between the particles of dirt, there's all the other components that are associated with loam and topsoil, and that's vegetation, both living and decomposing, and moisture. Those both impact how fast odor can move through that material. As we just saw, the soil type can have a big impact on how fast odor can move. So let's take a look at this. Now, the values I have at the bottom of this graphic here are very approximate. Please keep that in mind. It's just to give you a kind of a ballpark idea of how fast odor can move through materials. So gravel, so we're thinking like maybe ½ inch maybe 1 inch gravel, that's 20 to 40 inches per hour. It's really quick. Okay, you can set a hide and walk away and bring your dog back in 5 minutes, and the dog's probably going to hit it, depending on how deep it is. Whereas like coarse sand, getting smaller particles, but the void space is still decent size, that's 8 to 20 inches per hour. Okay, and now we go coarse sand, and again, if you notice, the particle size of the material is reducing, thus the void space is reducing. So fine sand is about 4 to 8 inches an hour. So, and you guys can go out there and kind of experiment and kind of see, what the soil types are like in your training area or your operational area, and then even do some tests to see when is that odor actually going to be available to the dog. And now the silty soils, this is where things get kind of interesting, because it's typically like a combination of sand and clays and that fine silt. So again, the void space is reducing, thus the speed in which an odor can move through it is reducing. And so the silty soils, it's about 4/10 of an inch to 4 inches an hour. And we talked about like the peat and the organics. That's a loam. That's like the topsoils. And it's, again, much slower. It's like 0.2 to 2 inches an hour. And that's coming back not necessarily from the void space, even though it's reduced, but also the presence of the vegetation and the moisture in it. And then the slowest, which we've already talked about, is the clays. And it's glacial in speed. It's 0.2 inches per hour. And so that can take a very long time. So again, kind of keep that in mind when you're looking at different soil types and how you're going to be burying or operating in certain environments, of what those soil types are and how it can influence the odor availability. Now, something to keep in mind, particularly with buried hides, is that the more recently that hide's buried, the more likely it is that that odor will be more easily available compared to a hide that's been buried for a long time. And the reason for that is, as you dig it up, or whoever digs up that hole to put the source in, that's loosening up the soil. It's increasing the void space. It could be the exact same soil type as surrounding it, but because it's been disturbed, it has more void space, and that allows the gas to transmit more quickly than the surrounding soil. It's compacted just due to time. And that's something that's important to keep in mind, that if it's a recent hide versus something that's been buried for weeks or months or even years, such as a pipeline. So that anytime you disturb the soil, it increases the void space, thus increasing the transmission rate of gases. And that can help you from the standpoint of training, but it can also make things a little complicated if you're looking for something that's months or even years old, such as a pipeline leak. Now, the other thing to keep in mind is if you have a uniform layer of material, okay, such as, let's say you got a pile of gravel that's covering it and covering the source, and because of the void spaces and that material, and it's spread out over a wide distance, that gas is actually going to spread out horizontally as well as vertically. So you may get a low concentration amount of odor over a large surface area of that pile. So again, something to kind of keep in mind. It's going to be much more difficult for the dog to get a point source in that type of environment, because the gas is going laterally as well as vertically. Now let's take a look at some models here. And what I want to see is, over here on the left, this is kind of the model setup. So each one of these rows is a different type of film material, and each column, if you will, is a different depth. Okay, so the depth is 6 inches deep on the left, 12 inches deep on the middle, and 2 feet deep on the right. But down here, this material that's covering it is coarse sand, so it's got a higher void space. This middle one is fine silt, so we're getting a tighter void space. And then the clays, well, we already talked about that. That's got the tightest pore space, so that's going to be the most difficult for gases to get through. And on the right, you can see this is just kind of a static test, so there's no air flows. This just gives you kind of an idea of how much odor is available. Now, it's important that even though I have different depths and different cover types, the source is exactly the same in all 9 holes. Okay, it's releasing the exact same amount of gas, but you can see visually how much of that gas is actually reaching the surface at the detection levels that the model has been set at. Okay, so that will give you an idea of not only depth, but material type that's covering it, how it can impact odor movement. Now, looking at the same thing, but with the dog zone, we've looked at this before. The dog zone is about half a meter above the ground. And you can again see the concentration levels. These are the exact same depth of holes, but it's a different soil types. And you can see how that larger void space in terms of the sand allows much higher concentrations and a broader expanse of odor availability. But again, just to help you visualize how much odor is coming out based on depth and different cover types. Now, the other thing to keep in mind is what happens when it hits the surface? Is there vegetation present? How tall is the vegetation? Is it really green vegetation with a lot of moisture? Is it dry? Those are all things to keep in mind. So we're just going to talk about a couple things. Here we got a nice profile of vegetation. So we got a hay field that we got a cut line right here, and you got the stubble. So that mimics kind of like a lawn or something like that. So very short grass, maybe 4 to 6 inches. And then you have this much taller stuff, but you notice it's really dense down in this lower portion. That's going to impact how that odor is going to diffuse and how far it's going to spread out, even in windy conditions. Okay, and so we're going to look a little bit at that. And so the biggest thing to remember is short grass will have the least amount of impact, and taller grass will have more of an impact, but it really is going to depend on how dense it is. Like before, we have the similar situation where I have 3 different holes in each one of these scenarios, and they're at different depths. At that 6 inches, 12 inches, 24 inches. Okay, but they're all with the same cover material. Okay, so the odor type and the amount of odor being released is the same, and the soil that is covering it is exactly the same. But what's different is, other than the depth, is this area over here is no grass, so basically like bare dirt or asphalt. Here's like on a lawn, and here's taller grass, not as thick as what I showed you there, so kind of like a wild, grassy field, so kind of sparse but tall, tall vegetation. Now, when I look at this from a static standpoint, so no wind is moving, you can see how far that odor spreads out in the no vegetation zone, and it's pretty high concentration. But even the lawn, you can see that grass there can impact how far that odor spreads out, and how to what extent and the heavy concentrations are reaching out. But then you get over here, you can see it's even more dramatic. That denser vegetation limits how far high concentrations of the odor will reach in a zero wind condition and even a low wind condition. Now we look at, like, say, 1 mile per hour. So this is a snapshot. This is after a certain time frame. I just wanted to kind of see. You can see these nice odor plumes out here, and we would expect this. The dog crosses that, they're going to be able to go right back to source. Here you're starting to see some variations in it. It's not as well defined, and it's like even stopping here, and you're wondering, it's like, well, why is this being pulled off over to the left? And what are these concentrations here? Well, what's happening is, you got to remember, this is like a cut line. So I have the short grass, and then I have this tall grass, and the wind is coming along here. And we've talked about this in prior videos, that this wind flow along this edge is actually going to pull the air in this area out. And that's why you're getting this hooking motion and then this concentration level down here. Okay, and that's what's occurring. And then here, what's happening is, you see this odor. This odor isn't stopping. It's just it's a low concentration from this point out to the edge of the vegetation. And then once it hits there, that dead air zone, and again, we've talked about that in prior videos, it's allowing it to concentrate again. So you can see this thick area of heavy concentration on the downwind side of a cut zone. So if you're working around hay fields and that kind of thing, kind of keep that in mind. Dog could be working on that downwind edge and get a strong hit. And then once you get in, and what you may want to do is look at, okay, if my dog got a hit here, I want to get a bearing on what the wind is doing, and then start my search pattern going back into it. So just something to kind of keep in mind. And this is the same model, but now with a 5 mile per hour wind, and we start seeing, as we've seen in prior videos, that deeper uh, odor source here, because it's reducing less odor, you're starting to see that odor plume diminish due to shear dispersion. Okay, so that is diffusing it and reducing concentration, so it's making it more difficult. And as the wind increases, you'll see this become more and more reduced and limited. And then here, these are still doing good. The grass makes a nice buffer and maintains that, so shear dispersion is not as impacting in vegetation. That's a good thing. And now you can start seeing here, you can start seeing variations of where the odor plume is doing. It's here, but you got these little pockets of higher concentration. And this is an ideal model. In the real world, it's going to even be more complicated, where this plume is going to be more dispersed and have a wider width that the dog's going to have to work. And just something to keep in mind as you're doing that and thinking, what's the wind doing? Because I know it's moving this odor. I just need to understand how it's doing it and what the vegetation is doing in terms of how it can impact it. And it's going to be hard, because if it's really thick vegetation, the dog may not want to be putting its nose down in. And that's something to keep in mind, is that, that plume may not be getting above the grass at detectable levels. So just something to keep in mind. In summary, the odor availability from buried hides depends on many factors. We talked about not only soil types, the moisture content, organics being present, and bigger void space based on different soils. That's obviously the main one. Bigger the void space, faster it's going to move. And then obviously the depth of the source. Okay, that's a no-brainer. And then the surface vegetation, that will have an impact on it, and you got to pay attention to that. And at least be aware of how it can be influencing it. Upcoming lessons, reaching the end of this series. Not sure what else I'm going to do beyond the next one. So mountainous terrain, I've been working on this for a while. I'm still trying to piece together how I want to do it. I want to look at terrain types and different vegetation zones, and actually try to incorporate some tracking. I have a lot of people who are doing search and rescue and apprehension tracking, and and I would like to incorporate that to kind of help out. But really, the next big thing is going to be an in-person class. I'm still trying to sort out dates on that. I'm hoping early summer, and that will be in Bozeman, Montana, and then we'll kind of see from there where it goes, and how well it's received. But that's going to be open to both civilian and law enforcement, with the full day open to everybody, and then the afternoon only open to professional dog handlers. So that would be search and rescue and law enforcement only. And so the sense sport groups, you're in the morning, and we're just going to cover the basics there. But then in the afternoon, we're going to get into more operational specific things that I don't feel is prudent to just put out there in the general public. So that's on the docket right now. Again, trying to line that out. Hoping maybe June, July. Is still, again, trying to figure out. And really, it's depending on when my certification conference is for my dogs. Hopefully this has been helpful for you. And as always, if you have questions, please reach out to me. And if you want to follow the antics of the Rotten Bomb Dogs, so that's our uh, Instagram page, and you can kind of see how we're doing there. And I'm always looking at and videoing my dogs, because I use that to actually see what the air is doing, and I use that to learn as much as anything. So thank you for your time. I hope this has been helpful. Have a great day.